Hello, this is Anthony Carruthers from the Better Lesson Master Teacher Project, and in this video I'll be talking about how I develop some math reading strategies with students. So method number 3 on the ways of proving that a quadrilateral is a parallelogram gives a good opportunity to develop some reading strategies. So just beginning the reading, it says, if a pair of opposite sides are both parallel and congruent, and then in the parentheses we have as shown. So with students I would say, hey, this is a good opportunity to look and see what they mean by as shown. So we look at the diagram and might ask, what do the tick marks mean? They tell us that segment DC is congruent to segment AB. What do the arrows mean? They tell us that segment DC is parallel to segment AB. Okay, and then moving on, we might say we know that angle 1 is congruent to angle 3. This would be a good place for a pair share and to ask, how do we know that angle 1 is congruent to angle 3? Students could either look at the parenthetical or they could look at the diagram to figure out why those angles should be congruent. And in any case, I'd want them to mark the information that was written within the text should also be marked on the diagram. So we show that angle 1 is congruent to angle 3. Hopefully they see that those are alternate interior angles, that AC is the transversal, and the parallel lines are DC and AB. Okay, moving on, we see since segment AC is congruent to itself by reflexive property, we would want to mark that, and in my class we mark it like that. And the conclusion based on that hypothesis is that we can say triangle ABC is congruent to triangle CDA by SAS. So I just try to emphasize to students that we don't just take the words in the text on face value. We want to square them with what we see in the diagram. So it says triangle ABC, which is the lower triangle, is congruent to triangle CDA, the upper triangle, by SAS. So let's confirm that. Okay, we have a side, an angle, and a side in the first triangle. And in the second triangle, we also have a side, an angle, and a side. So in that way, the diagram confirms what we read in the text, so we can be sure that we're understanding things correctly. Okay, once we know the triangles are congruent, we can say angle 2 is congruent to angle 4 by CPCTC, and segment AD is parallel to segment BC by the converse of the alternate interior angles theorem. So this is a good example of how reading all the way through a math sentence can be sometimes useless. So we want to chunk this a little bit and understand how this provides a logical sequence of things. So first, starting with, once we know the triangles are congruent. Okay, well, referring back to the previous sentence, we established that triangle ABC was congruent to triangle CDA. Okay, well, what does knowing that tell us? Well, it tells us that angle 2 is congruent to angle 4. Okay, how do we know? Okay, well, CPCTC tells us that angle 2 is congruent to angle 4 because the corresponding parts of these two congruent triangles must also be congruent. So in that way, we're just trying to slow things down a little bit so that students can digest this sentence piece by piece rather than trying to speed through it. Okay, so now we know that angle 2 is congruent to angle 4, and that leads us to segment AD somehow being parallel to segment BC. So how do two congruent angles lead us to these segments being parallel? Well, the text says by the converse of the alternate interior angles theorem. So we have some marking to do on the diagram. I would want to mark angle 2 and angle 4 congruent. And according to the text, because those two are congruent, it makes this segment here parallel to this segment here. Okay, so we want to see how those two things go together. So angle 2 and angle 4 are alternate interior angles, and because they're congruent, that's why those two sides are parallel. So now it makes sense to us when we read, because angle 2 and angle 4 are congruent, segment AD is parallel to segment BC by the converse of the alternate interior angles theorem. Okay, moving on, proving that a quadrilateral has one pair of sides that are both parallel and congruent. Okay, just remind ourselves those were the initial conditions. is sufficient to show that the quadrilateral fits the definition of parallelogram. Okay, again, we don't take that on face value. What do they mean by fits the definition of parallelogram? Well, the definition is it has two pairs of parallel sides. So based on our initial conditions, one of the sides was already given as parallel, and we showed that that would lead us to the other two sides also being parallel. So in that way, this criterion is actually sufficient to prove that the quadrilateral is a parallelogram. So once again, my name is Anthony Carruthers from the Better Lesson Master Teacher Project. Hope this has been helpful. Teach well.